Hello everyone and welcome to Network Playroom. This is the 16th video in the Christmas calendar series, and today we're going to leave spanning tree behind and move on to BGP. I've been studying BGP lately, so several following videos will probably deal with BGP. But we'll start from the basics and look at BGP session establishment in this video. So if you're familiar with how IGPs like EIGRP or OSPF become neighbors or form adjacencies, forget that for now because the operation is different for BGP. Now first, IGPs discover neighbors automatically once the protocol is enabled, but BGP must be explicitly configured to peer with another BGP speaker. And second, IGPs use their own transport protocol, for example, protocol number 88 for EIGRP and protocol number 89 for OSPF, whereas BGP relies on TCP for reliable transport. And now there are 6 distinct phases in a BGP session establishment, but because BGP takes advantage of TCP, the full BGP session establishment actually consists of 2 major phases. Number 1, establishing the TCP connection between the peers, and number 2, establishing the BGP session. So the first 3 states are involved in establishing the TCP connection, and they are idle, connect, and active. And after the TCP connection is in place, the following 3 stages complete the BGP session establishment, and they are open send, open confirm, and established. So let me write those down here. So idle, connected, or connect, and number 3, active. So these are involved with the TCP session establishment, and then the remaining ones, so open send and open confirm, and finally established, are involved with the BGP session. Established, if I could spell. There we go. So this is the actual BGP part. Now let me be clear here that the BGP session is dependent on the TCP connection, but a successful TCP connection does not automatically mean the BGP session will be established. BGP speakers can still fail to become peers if they disagree on BGP parameters and such. So you cannot move to these states until the TCP connection is established. But in case TCP works, it doesn't mean that this part necessarily works. But we'll look at that more in a moment. So let's look at the first 3 states in more detail, and I have a diagram from Cisco Press here to illustrate the states and the relationships between them. And there's also something called the connect retry timer that plays an important role in pacing the phases. So pay attention to that. But let's start with number 1 here, the idle state. So this is the first state of the BGP session establishment. BGP detects a start event and then tries to initiate a TCP connection to the BGP peer, and also listens for a new connection from a peer router. But if an error causes BGP to go back to the idle state for a second time, the connect retry timer is set to 60 seconds and must decrement to 0 before the connection is initiated again. And further failures to leave the idle state result in the connect retry timer doubling in length from the previous time. Now let's move on to number 2, which is the connect state. So in this state, BGP initiates the TCP connection, and if the three-way TCP handshake completes, the BGP process resets the connect retry timer and sends the open message to the neighbor and then changes to the open send state. And during this state, the neighbor with the higher IP address manages the connection, and the router initiating the request uses a dynamic source port, but the destination port is always 179. So yeah, here you can see that TCP makes use of the client-server model, and clients connect to the server, and the server listens for incoming connections. And in the case of BGP, servers use TCP port 179. And BGP speakers complete the three-way handshake before moving on to the BGP session establishment. And next, there's number 3, which is the active state. And in this state, BGP starts a new three-way handshake. If a connection is established, an open message is sent, the hold timer is set to 4 minutes, and the state moves to open send. And if this attempt for TCP connection fails, the state moves back to the connect state and resets the connect retry timer. So after the connection is set, BGP speakers exchange BGP messages to complete the BGP session establishment. So open, keep alive, notification, and update packets are sent and received in the last 3 BGP states. And we'll discuss the BGP packets at another time, but now let's look at the final BGP states in more detail. So number 4 is open send, and in this state, an open message has been sent from the originating router and is awaiting an open message from the other router. So after the originating router receives the open message from the other router, both open messages are checked for errors, and the following items are being compared. Things like PGP versions must match, the source IP address of the open message must match the IP address that is configured for the neighbor, and the AS number in the open message must match to what is configured for the router. And the PGP identifiers, the router IDs, must be unique. And if a router ID does not exist, this condition is also not met. And then lastly, security parameters must match, such as password and TTL and the like. So in this state here, some checks are performed, such as PGP version and the source IP and the AS number and the router IDs. So RID and then the security parameters. Oh, okay, let me do this, security parameters. There we go. And now we're in state number 5, which is open confirm. And in this state, PGP waits for a keep alive or notification message. Upon receipt of a neighbor's keep alive, the state is moved to established. And if the hold timer expires, a stop event occurs, or a notification message is received and the state is moved back to idle. And then finally, number 6 is established. And in this state, the BGP session is established. BGP neighbors exchange routes via update messages. And as update and keep alive messages are received, the hold timer is reset. And if the hold timer expires, an error is detected and BGP moves the neighbor back to the idle state. So that's really a summary of the BGP states. And as you can see from the diagram, basically anytime an error situation happens, the connection moves back to the idle state. and that's the starting point of PGP session establishment. But now that we've gone over the PGP states, let's look at a packet capture. And of course, it's from packetlife.net again. So in the first part here, in the first 3 packets, you can see, can I highlight this or not? There we go. Something quirky is happening. Okay, but the first 3 packets anyway, you can see that the protocol is TCP. And here you can see there's a random source port and the destination port is 179, which is PGP. So this was the SYN packet and then the SYN ACK. So the server is responding from source port 179 for PGP to that random port from the client. And then finally, the client sends an ACK back to the server. So this completes the 3-way handshake. And then in the next part, you can see the open messages being sent, open messages, keep alives, and update messages. And these are involved in the final 3 states, in the final 3 PGP states. So if we look at this information here, well, we're going to look at these packets in more detail later on, but there are some interesting fields that I just want to briefly show to you, like these capabilities. These are very useful in PGP, and this is something that also separates PGP from other routing protocols, these optional capabilities. But we'll look at those in another video. Here's a keep alive message and then update messages. But here you can clearly see that the first part is the TCP part and then the rest is PGP. So the TCP 3-way handshake completes first, and then you move on to the PGP session establishment. But that's really it for this video. Thank you again for watching, and I'll see you in the next video.